Okay, so this video is meant for pre-calc. This is going to be broken into two videos. So again, there will be two videos. One will be on geometric sequences and one on geometric series. So two YouTube videos. Alright. So hope everybody had fun at prom and was safe. Okay, so now we're moving away from arithmetic to geometric. And when you think of geometric now, the key word is exponential. Okay, so this is the word that you should think about for geometric, exponential. So for arithmetic, it was linear. For this geometric sequence and series, it's exponential. All right. Okay, so what happens here for a geometric sequence is that it's not a common difference, but now it is a common ratio. So for a sequence to be geometric, okay, so for a geometric sequence, the ratios of consecutive terms is the same. Okay, so if you have a sequence, a sub 1, a sub 2, so on and so forth. If you divide the farther term divided by the closer term, so a sub 2 divided by a sub 1, you get this ratio of r. And again, and so on, a sub 3 divided by a sub 2, and you get this common ratio of r. And that's what you're looking for, r. R is the common ratio. Okay, so that's what makes a sequence geometric, common ratio. So let's do a couple here. Let's take a look at the first one, a. So let's list out the first couple terms of this sequence, 2 to the n. So a sub 1 is 2 to the first, which is 2. A sub 2 is 2 to the second, which is 4. And a sub 3 is 2 to the third, which is 8. And now what we'll do is let's take a couple ratios. So let's do a sub 3 divided by a sub 2. That would be 8 divided by 4. And you see that that ratio comes out to be 2. And now let's do a sub 2 divided by a sub 1. That is 4 divided by 2, and that again is 2. So this sequence is geometric, and that common ratio is 2. Okay. We'll do B as well. So for B, a sub 1 would be 4 times 3 to the first. 3 to the first is 3. 3 times 4 is 12. A sub 2 will be 4 times 3 to the second. 3 to the second is 9. 9 times 4 is 36. A sub 3 is 4 times 3 to the third. 3 to the third is 27. 27 times 4, I believe, is 108. Yes. So now I just listed out the first couple terms, and now what we'll do is we'll find the ratios. So a sub 3 over a sub 2 is 108 divided by 36. And when you divide these, it divides evenly. You get 3. When you take a sub 2 divided by a sub 1, 36 divided by 12, you get 3 again. So this common ratio that comes out is 3. Okay, and we'll skip C. So now let's talk about some structure again. So we said that geometric means exponential. So if you look here, an exponential function has the general form y equals a b to the x. Okay? And again, this b is only raised to the x. So sometimes you see, the b to the x in parentheses. Okay? So what is the common ratio in terms of that exponential? Well, the common ratio for the first problem was 2, and the common ratio for the second problem was 3. That is the number that is the base of the exponent. So this b, the base, is the ratio. Okay? So understand the structure here. So that base of the exponent is going to be the ratio, that common ratio between your terms. Alright. Okay. So now, how do we find the nth term of a geometric sequence? Well, here's your formula. To find the nth term, a sub n equals a sub 1, the first term, times that common ratio to the n minus 1 power. Okay? This is very similar to the arithmetic sequence. A sub n equals a sub 1 plus n minus 1 times d. Very similar for the arithmetic. Okay? The one that we've been using on the board here to the right. Okay. So again, you'll see what your terms come out to be. So a sub 1 is the first term. The second term is a sub 1 times r. So again, you multiply by that ratio to get the next number. The third term is a sub 1 times r squared. So notice your exponent is the nth number. So 3 minus 1 is 2 for that third term's exponents. All right. So down here they give you a recursion formula. So if you remember the recursion idea, so if you want to find the next term, take the previous term and times it by the ratio. So this is the recursive formula. Recursive. And again, in layman's terms, to find the next term, multiply previous term by r. There we go. Okay. All right. So again, we'll add this formula to the board on the right if it's not already done so for you. Okay, let's see. So write the first 5 terms of the geometric sequence, whose first term is a sub 1 equals 3, and whose common ratio is r equals 2. And then graph the terms on the set of coordinate axes. Okay. So I need to build the equation. So a sub n equals a sub 1 times r to the n minus 1. So a sub n equals a sub 1 is 3 times r, which is 2, to the n minus 1 power. Okay? Alright, so there's my nth term. So now I will simply plug in. So a sub 1 was given to us. That is 3. Now again, you can use the recursion idea. Just take that previous term and multiply by the r. I'm going to plug into the a sub nth formula though. So a sub 2 equals 3 times 2 to the 2 minus 1. That is 3 times 2 to the first. That's 6. So again, take the previous term, times it by the ratio. 3 times 2 is 6. Using recursion, the next number should be a 12. Let's see. 3 times 2 to the 3 minus 1 power. 3 minus 1 is 2. 2 to the second is 4. 4 times 3 is 12. There you go. A sub 4 is 3 times 2 to the 4 minus 1. 4 minus 1 is 3. 2 to the third is 8. 8 times 3 is 24. Again, 2 times 12. And then a sub 5. 3. 2 to the fifth minus 1. This will come out to be 48. And just a quick graph here. So when you graph these problems, make sure your x is your n, your y is your a sub n. Again, I'm not even going to... oh no, I will. So let's let the x-axis be counting by ones. Something like that, so I need 5. The y-axis, I need to get to 48, so let's count by tens. So I'm counting those by tens, and I'm counting the n's by ones. So we have 1, 3, which is like somewhere right here. We have 2, 6, which is somewhere right there. We have 3, 12, which is somewhere up here. We have 4, 24, which is somewhere right here. and we have 548, which is somewhere up here. And notice the shape. If I was to connect these with a dotted line or dotted curve, look what happens. And if you remember from earlier in this class or from Algebra 2, this is an exponential curve. And that's why when you think of geometric, you should think of exponential. Questions there? Cool. All right. Next, here we go. Find the 15th term of the geometric sequence. So I suppose, back in this problem, we should understand when it tells us geometric sequence what that means, right? So geometric sequence means something. Whose first term is 20 and whose common ratio is 1.05. So here, the first term is 20. And the common ratio is 1.05. So let's see if I can fill in my formula. My formula, a sub n equals the first term, a sub 1 times r to the n minus 1. So if I fill in the general formula, a sub n equals a sub 1 times 1.05 to the n minus 1. Okay? All right. Now, sometimes, I know how I wrote this with the exponent inside. Sometimes you'll see the book write it with the exponent on the outside. Okay? Especially if that ratio is negative. That's a very important idea because a negative raised to an exponent behaves, positive and negative in that alternating fashion. So be aware of that idea and how they decide to write the exponent, especially if it's a negative number. Okay, so like this one, you'll see if you look in the textbook, they actually did do that, and that's why with this decimal, put the 105 in parentheses and the n minus 1 on the outside. Okay. All right, so now we want the 15th term. So what is a sub 15? Well, that's 20 times 1.05 to the 15 minus 1. And now we'll just type this in. I would suggest you use 14 as the exponent, not 15 minus 1. So 20 parentheses 1.05 raised to the 14th. And I get something like 39 point, and we'll just go 39.6. You get 5986. That rounds up to 0.6. Okay. So just follow the directions that they ask for certain decimals. Questions here? Should not be. Okay. Next, finding a term of a geometric sequence. Find the 12th term of the geometric sequence. And they give us some numbers, 5, 15, 45. So knowing that it's a geometric sequence is very helpful because you will know that you're looking for a common ratio. Now we are looking for the 12th term. I need to find the formula. Now I could keep going. This is the first, second, third term. This is a sub 1, a sub 2, a sub 3. I could keep going until I find the a sub 12th, the 12th term, but I'm going to be more clever than that. I'm going to find the common ratio by taking any two consecutive. Let's take just the first two, right? So let's take a sub, so the ratio, r, a sub 2 over a sub 1 is 15 over 5, which is 3. So now my formula, and I'll do it right here, a sub n equals a sub 1 times r to the n minus 1. A sub n equals, my a sub 1 is 5 times 3 to the n minus 1. And again, 3 in parentheses, 3 with the exponent in parentheses, 3 is an okay number to work with. So I want the 12th term. A sub 12 is 5 times 3 to the 12 minus 1. That exponent is 11. 5 times 3 to the 11th. And I get the 12th term to be 885, 735. So you see how this stuff grows very quickly. It grows very, very quickly. Okay? Alright. Next. Okay, here we go. Find the fourth term of a geometric sequence. The fourth term of a geometric sequence is 125. And the 10th term is 125 over 64. Find the 14th term and assume that the terms of the sequence are positive. Okay, so that means there's not an alternation. So that's going to mean that my ratio, assume that they're positive, means that R is positive, right? Again, if R is a negative number, your terms are going to alternate sign because you have odd exponents and even exponents. So the fact that all of the terms in the sequence are positive means that our ratio is positive. Okay, so here's what I will do. I will find the ratio, okay, by using that formula, a sub n equals a to the first r to the n minus 1. So here's my formula. Okay. However, we're not given the first term. Okay? We're given the fourth term, so I know that a sub 4 is 125, and I know that a sub 10 is 125 over 64. That's what I know. So now, we did a similar problem to this with the arithmetic sequence. So what I'm going to do is I'm going to find the ratio between the a sub 10th and the a sub 4th. I'm going to do it right over here. So a sub 10 over a sub 4 equals 125 over 64 divided by 125. And again, if you want to use a calculator, you can. This problem you can do by hand, though. Okay, it actually comes out very nicely because, remember, write this left to right. This is 125 over 64. And then instead of dividing by 125 over 1, times by the reciprocal. So if you go back to that trig stuff where we did all those, pi's over pi's, that kind of stuff. And now notice, the 125 is on top and bottom. It'll cancel, and you get 1 over 64. And that is the common rate. That's the ratio between the a sub 10th term and the a sub 4th term. Okay? But how many terms are between these two? There are 6 terms. Okay? So if you remember with the arithmetic, you took the number and divided by 6. Because with the difference was just being added on however many times the difference was. So there were 6 terms in between, so you're adding 6 differences. Well, here, the way that the geometric sequence works is it's exponential. So this 164 is really the common ratio raised to the 6th power. So the 6 terms translates into the exponent of the ratio. That again says I'm multiplying by the ratio 6 times. I don't add the ratio, I multiply by the ratio. So it's ratio times ratio times ratio, and when you multiply like bases, you add their exponents. So this is really r to the 6th. We need to find r, so you would take the 6th root of this. And again, because this is an even index, you could potentially get 2 answers, positive and negative. But because it says assume that the terms are positive, this is going to be a positive ratio. And you can use your calculator to do this. You can use the X root button. So if you remember under math, so if you type in the calculator, so in the calculator, I'll do that right here, calculator. So I would type in 6, I'd go math, 6 math, and you go down to the 5th selection, which is the X root. And when you do this, you should open a parenthesis and do 1 divided by 64. And close your parenthesis. So this is the calculator. So 6 math x root 1 divided by 64. Close parenthesis. And you get a decimal of 0.5, or the common ratio is 1/2. So this is a tricky problem here. So again, if they give you two non-consecutive, so this is again a non-consecutive problem. I'll write that right here. Non-consecutive. So if they give you two non-consecutive terms, find the ratio, and then understand how many terms are between, and take that root, and you'll get the common ratio between consecutive terms. So now I can fill in this problem. So I would like a sub n equals, so I still need the a sub first term, but I now have the common ratio of 1/2. So how do I find the a sub first term? Well, you have some a sub n's, you have a sub 4 and a sub 10. Plug them in. Let's plug in a sub 4 because it's not a fraction. So a sub 4 equals a sub 1 times 1/2 to the 4 minus 1. A sub 4 is 125. 125 equals a sub 1 times 1/2 to the 4 minus 1. 4 minus 1 is 3. 1/2 to the third power is 1 to the third and 2 to the third. That is 1/8. And now I'll times both sides by 8. And when I do that, I get an a sub 1 value. I'm going to scoot this down. I'm running out of room here. This is quite a hefty problem. I get an a sub 1 value of 8 times 125, which is 1,000. So now I'm actually going to move this to the next slide because I do need to do, it just needs one little thing. So I will rewrite this formula, the a sub nth, filling in my a sub 1, which is now 1,000, and my r, which is 1/2. So a sub n, again, equals a sub 1. You don't have to write this general formula down, but I will. So a sub n equals 1,000 times 1/2 to the n minus 1. So there is my geometric sequence a sub nth formula, and now I need the 14th term. I'll type that in my calculator. 1,000 times 1/2 to the 13th power. I get a decimal of 0.122, but I wonder if I do 2 fraction, if it'll give me a nice fraction, and it does. So if I do 2 fraction, a sub 14 equals 125 over 1,024. So again, I don't know what the directions are going to call for. If the back of the book asks for the nice answer in fraction form, make sure you do that so it agrees. Again, I will let you know on a quiz or test what you need to do, so make sure you can do both. Okay. So this is a tricky problem when there's non-consecutive. So just to review one last time, take the two terms you get, divide them. That'll give you some sort of the ratio, but it's to some power. That power is the number of terms in between them. So to find the common ratio between consecutive terms, you must take that root of how many terms there are in between the numbers they give you. So again, between 4 and 10, there are 6 terms. So we take the 6th root of that ratio, and that comes out to be your common ratio of r, 1/2. And then we had to go back and find the a sub first term, so we had it in the formula. And then, once we did that, we could find the a sub 14th term. Now, I suppose you could continue on from this 10th term. If you need to find the 14th term, you can multiply that by 1/2, and then the next term by 1/2, and the next term, and the next term, and that gets you the 14th term using recursion. Okay, but I would suggest we stick with this formula. I think that it will be better for us. Okay, all right. So this is the first part. We'll go to the sums, the second part.